All right, so we talked about higher order functions to prepare for decorators. Now let's move on and talk about decorators. So a good place to start is just defining what a decorator actually is. So a decorator is simply a function, but more importantly, it's a function that wraps other functions, enhancing or changing the behavior of the function that is being wrapped. There are examples of higher order functions, and decorators also have their own special syntax. You can use the @ sign. It's just a shorter syntax, but we don't have to use it, but we should. But first, I'm going to show you how to set up a decorator, just a wrapper function that enhances the behavior of another function without using the syntactic sugar, and then we'll see the nicer way of doing it. Okay, so let's take a look at that first example. So here we have our basic function called greet, and it just prints, my name is Colt. All right, but then we have this other function called be polite that takes a function as an argument, higher order function. And not only does it take a function as an argument, it actually returns another function that's defined inside. So we have a function that we're calling wrapper. It does not have to be called that, it can be called anything, but we're going to return it from be polite. And all that it does is print, what a pleasure to meet you, and then it executes function, whatever was passed in, and then it prints, have a great day. And at this point, these two functions have nothing to do with one another, totally separate. But then there's this line. This is where we start to decorate our function, where we take greet and we pass it in to be polite, and we save the result that's returned, the wrapper function, to a new variable. In this case, we're just calling it greet. So greet is equal to the result of passing greet into be polite. And the result of that is that we get a function that takes this functionality and sandwiches it between what a pleasure to meet you and have a great day. Okay, so I have the same code here in the file, and all we need to do is then execute greet. Let's do it 3 times. And we get, what a pleasure to meet you, my name is Colt, have a great day. That's the first time, then the second time, then the third time. All right, so hopefully you can see how we are wrapping this function greet inside of another function. We're returning it, and then we're storing it in a variable called greet. We could call it wrapped greet or something like that, but I'm just going to go with greet. But I want to be clear, that name doesn't matter, but whatever is here is what you would call. But in a moment, I'll show you the nice syntax that Python adds, so we don't ever even have to do this line. But I just want to make sure that everyone's comfortable, or as many people as possible are comfortable with the idea of having a function that returns this wrapper, and the wrapper does something first, then does a function that we passed in, greet, and then does something else. So we could do another one where we have, I don't know, def rage, print I hate you, like this. And then we could define polite rage equals be polite rage. And then down here, I just need to call polite rage. And that gives us, what a pleasure to meet you, I hate you, have a great day. So you can see we're wrapping this code or this function with functionality. Now the utility of decorators comes in when we're not just printing polite sentences, but we start to add other functionality around things, and I'll show examples in a future video in this section that actually show why you would use that. But next, let's look at the syntactic sugar I've been mentioning using that @ sign that helps us create a decorator faster. Okay, so here is that syntactic sugar. We have our 2 functions, they are unchanged. But the difference is that I'm now putting this @ be polite, the name of this function here, on the line before I'm defining whatever the function is that I want to be wrapped. And Python takes care of the rest. I don't have to do this anymore. It automatically does this. So whenever I call greet, it's basically the same as me having a variable called greet. Well, it is the same, which is the result of calling be polite with greet and that wrapper function that's returned. Instead, we just have to write this. So we can test it out. All I have to do here is just do @be polite. And I can get rid of all of these lines down here now. Get rid of that as well. And if I call greet, let's see what happens. There we go. What a pleasure to meet you. My name is Colt. Have a great day. Notice it only applies to this function. If I wanted it to apply to rage, I could do that. Nothing wrong with that. I can call rage afterwards. And there we go. We get both functions now being wrapped. So very nice syntax. This is something that not every programming language I've worked in supports, and I'm a big fan of it. I think it's nice. Some criticisms of it might be that it's a little over the top, that it's trying to be too nice and tidy, and that it obfuscates what's actually happening. But I personally think that it's a nice touch. But remember, you do not have to use it. We could do the exact same thing with what we already saw, where we could do something like rage now equals be polite of rage. This is doing that. And the cool thing is it automatically gives it the name rage. So earlier when I was doing something like polite rage, I had to then call polite rage down here. But when we add the decorator with the syntactic sugar, it automatically just uses the exact same name. So I can just do this. And now I call rage and it's automatically wrapped with whatever we had up here. All right, I'll end this video here. Decorators are just functions that accept other functions, they wrap them with some other functionality and return that wrapper function. But then the cool thing in Python is we can use this at decorator syntactic sugar in front of a function definition. We put at whatever. We saw at class method. That does the exact same thing, except we didn't define class method. It was defined for us. Instead, we can use some function that we've defined. We put it in front of whatever function we're defining, and it's wrapped.